In this video, we're going to discuss quartiles, and then we'll discuss how to calculate quartiles in an example. Okay, so the basic idea behind quartiles, imagine you have your data lining up on a number line, right? So your data is all sorts of points on the number line, right? What quartiles are, basically they separate the data into 4 boxes that each contain 25% of the data. Okay, so 25% of the data is in this box, 25% is in that, 25% is in there, right? So all the boxes contain all of the data, right? That adds up to 100% of the data, right? So quartiles break the data into basically 4 boxes. There are 3 quartiles, right? This line here, this would be whatever the minimum data value is, right? And this line up top here would be whatever the maximum data value is. So then these 3 lines in the center are the 3 quartiles. So they're usually noted with Q1, Q2, and Q3. Okay, so let's see. Quartiles are the same thing as percentiles, right? 25% of the data is less than whatever this Q1, and that's basically the definition of the 25th percentile, right? So P25, or the 25th percentile, that's the notation for the 25th percentile, is the same thing as Q1, which is the first quartile, right? So 25% of the data is less than whatever the first quartile is. Right. Then we have the second quartile, and that will be actually, so that's 25 and then plus another 25. So 50% of the data is less than whatever the second quartile mark is. So P50 is the second quartile, and actually 50% of the data is behind the first quartile. 50% of the data is actually behind the second quartile, and 50% of the data is actually also in front of the second quartile, which means that the second quartile is actually the median, right? It's halfway through the data. So the second quartile is also the median. All right, lastly, we have the third quartile, and let's see, 25% plus another 25% plus another 25%, looks like 75% of the data is less than the third quartile. So the third quartile is called the 75th percentile. Third quartile is the 75th percentile. All right. So if you're good at calculating percentiles, you'll be good at calculating quartiles, right? To calculate the first quartile, all you need to do is look at your data and calculate the 25th percentile. Right, so let's go ahead and let's try doing this. Let's practice calculating percentiles. So I have some data from the number of home runs for a random sample of NBL players. So this is the number of home runs that they've made. So let's start. We want to remember the equation for calculating percentiles first. So remember this equation, it was in a previous video. This tells us the location of the percentile. So we're going to use this equation to calculate these quartiles. Remember, K is whatever percentile you're looking for. So it'll either be 25, 50, or 75. And then N is the sample size. Okay, so let's see. Looks like we have 14 data points here. Okay, so if you count them up, there should be 14 numbers here. So N is going to be 14. And L will be the location of the percentile. But first you need to sort the data, right? The location of the sorted data. Right? All right, so let's go ahead and first sort the data. I've already done that here. Okay. All right, so I've already sorted the data. So first, let's go ahead and start by calculating the 25th percentile or the the 25th percentile of the first quartile. Okay, so let's start by calculating Q1. Okay, so to calculate Q1, I'm going to first calculate L. It's going to be 25 over 100 times N is 14. So that's 0.25 times 14. Should come out to be 3.5. Okay, so remember, whenever L is a decimal, you round up to the next number, right? You always round up to the next number whenever L is a decimal. So this means we should go to the fourth observation for sorted data. So 1, 2, 3, 4. 6 is the fourth observation. So the first quartile is 6. All right, now let's talk about calculating the second quartile. Let me go ahead and change colors actually. So let's go ahead and talk about the second quartile. All right, so to calculate the second quartile, the same thing as the median, right? But I can still use this equation, 50, and that times 14, right? So 0.5 times 14, that'll give you 7. Right. Remember, whenever L is a solid number, the rule is whenever L is a whole number, you should average that whole number and the next. So 7 and 8. So here's 4, 5, 6, 7, 8. Right. So if we average 9 and 10, that'll be the median or the second quartile. Okay, so average 9 and 10. 9 plus 10 divided by 2 is 9.5. Right. Lastly, let's go ahead and calculate the third quartile. So let's use this L equation one more time. Now it's 75 divided by 100 times 14. So that's 0.75 times 14. Which would come out to 10.5. Okay, so since that's a decimal, you'll take it to the next whole number to 11. So there's 8, 9, 10, 11. So the 11th ranked observation is 14. So the third quartile is 14. Okay, so you could interpret these and you'd say, all right, well, the 25% of the players have less than 6 home runs. 50% of the players have less than 9.5 home runs. Actually, and also 50% have more than 9.5 home runs, right? That's the median. And then lastly, you could interpret the third quartile as saying, all right, well, 75% of the players have less than 14 home runs. You could switch it up and say, well, because 75% have less than 14, that means that 25% have more than 14 home runs.